So this will be the one of the problems for section 6.3. This homework is due like a week from now. I'm gonna just do this one because I had a request for it, and I think it's probably a good problem to understand what's going on. So it's going to be similar to, I think, problem 3 in WebAssign in the book. The problem that they got it from was 6.3.2. That's the one I'm going to do. They just changed some numbers, but it's going to be the same idea. So they give us this graph here. This is y is equal to sine x squared. And this here is the point radical pi. So they give us this and to begin with, and they say, okay, sketch an approximating shell. What else do they want us to do? Find its circumference and height. And then use shells to determine volume when rotated about y-axis. So what we're doing here, and this looks kind of like the one of the examples I did, and the notes is, I'm going to rotate this thing. Oops. I'm going to rotate this thing, get something that when cut in half looks like this. And so the typical approximating rectangle, or the typical approximating shell, is I'm just going to use, this almost hollow cylinder that looks something like this. And then let's see. Look like that. And so, the idea is, when I'm looking down on these cylinders, what I'm seeing is it's not a washer because it has, depth. So, I can draw this. So let's do a different kind of view. So it's going to be this sort of shell thing that I'm looking at. And so what you need to remember is that the volume of these things. So what do they ask us to do? Okay, so we've sketched an approximating shell, find its circumference and its height. Okay, so circumference then we can do. Circumference is pretty easy, so you can see, that we're talking about the circumference of the circle. So the circumference is given by 2 pi, for a circle, it's given by 2 pi times the radius. So what I'm looking for is I'm looking for this radius here. So I'm looking for that length there. You can see here that it's just given by the x coordinate. So this is just going to be 2 pi x. So whatever the x coordinate of my shell is the radius of the shell. And the height, very similarly, it's the y coordinate. And the y coordinate is sine of x squared in this case. So I've done that. I've sketched an approximating shell. I found its circumference and its height. Now I'm going to use shells to determine the volume. So the way we do that is volume is going to be the integral over my region A to B of the circumference times height. And let's figure out if it's dx or dy. So to do that, you ask yourself, okay, which direction is the thickness of the shells going? Here it's going in the x direction. This will be a dx here, which makes things a little easier for us. And then, okay, so think about our bounds. Where does x start? Where does it end? I'm only thinking in terms of half of this thing. X starts at 0, ends at the square root of pi. So I start at 0, end at the square root of pi. Sine circumference was 2 pi x. Sine of x squared dx. So let me go back and kind of just point out, just in case I didn't hit it hard enough, because I know I glossed over it. The height of the shell is given by the function that we're on, and the function that we're on is y is equal to sine x squared. So the height's given by the y coordinate, and y is just sine of x squared, which is why I wrote that. I made sure all of my, my variables match my differential there. This is a square root of pi, clean that up. Okay, so this is the integral, so I'm gonna pull the 2 pi out, integral from 0 to the square root of pi, x sine of x squared, dx. So you look at this and you're trying to integrate it, well, you can't think of any derivative off the top of your head. You can see an x squared here and you think, okay, the derivative of x squared is 2x. And I have an x right here, so that looks like a good u substitution. If I let u equal to x squared, du will be 2x dx, and dx will be 1 over 2x du. So then this is 2 pi times the integral. I'm going to change my bounds here again. The u of x is x squared. U of 0 is 0 then, and u of the square root of pi is square root of pi squared, which is pi. This is the integral from 0 to pi, x sine of u, and then dx is 1 over 2x du. I can see here my x's cancel. What I'm going to be left with is 2 pi times the integral from 0 to pi sine of u 1/2 du. All right, just doing some more simplifications. My 2's go away there. So this is pi times the integral from 0 to pi sine of u du. And now we just integrate this, because now I know how to integrate sine. So this is pi times minus cosine of u, evaluated from 0 to pi. So this is pi times minus cosine of pi minus cosine of 0. One more. This is pi times negative cosine of pi is minus 1, cosine of 0 is 1. So this is 2 pi, it looks like. And that's, that's the shell method. You'll get plenty of practice with this homework. I know these homeworks are long. They will teach you how to do it though. So you want to start these early. That way you're not just rushing through trying to do all of these. You're actually learning as you're doing these. So if you have questions about this, or you want to see another problem from this section, let me know and I'll do it. I'm not going to pick one tonight, because it's, with these problems, I know that they're harder, and I want you guys to figure out what you don't know how to do and let me know. That way I'm not just doing problems that aren't helping anybody. So I'm going to stop there. Upload these tonight.